Nicolás Peppas se formó como ingeniero químico en su Grecia natal. Tras doctorarse en el Instituto Tecnológico de Massachusetts, ha desarrollado una carrera internacional, logrando centenares de discípulos y colaboradores de varios países. Pionero en la física de polímeros y los bio-nanomateriales para administrar fármacos, actualmente forma parte de 18 academias científicas y ostenta 15 doctorados honoris causa, incluido el de la Universidad de La Laguna.
Good morning, and thank you very much for inviting me for this interview. I am delighted to be here at the University de La Laguna. And yes, there has been a very large number of recognitions throughout the globe. But for me, the excitement is a recognition of the research we have done and the data, the results we have achieved, and frankly, the people that we have been able to treat and to help with everything we have done. So I'm delighted that La Laguna is also doing this. And it is a very pleasant experience for me to be back in Santa Cruz and in La Laguna for this particular visit. I was here in 2019, yes, and I gave a series of lectures in English about the field of pharmaceutical technology and how this field has helped develop new formulations, new products that are helpful to our patients. This is a very good question because deep in my heart, as a scientist and as an engineer, I work because I want to solve problems. I solve problems in areas where I feel competent to solve them. I believe that people who have an interest in helping their countries and in helping their people can have a main profession, a focalization, as you call it, an area where they are particularly experts, but at the same time, they can contribute to other areas with part of their work. So I was a chemical engineer, and I'm still a chemical engineer, but I'm also a biomedical engineer because I am interested in medical aspects. If I may take your time, for me, the chemical plant and the body are the same thing. In the chemical plant, we put something and we process it to make something else. In the body, we do the same thing. We take a sweet product and we put it in our body and it changes our glucose, and therefore we cannot process our glucose and we have to take insulin to avoid diabetes. So it is the same process. The mathematics, the chemistry, the physics is the same. What is different is in one case is an inanimate body, and in another case, of course, is the real body. In the last 20 years, the area of nanotechnology has become very important. For me, that's a natural subject to extend. So we got into nanotechnology to help what we do in the other areas. The word existed, but only very few people knew about it, okay? There were more important problems to solve. When I started, people were dying because their kidneys could not function well. And we had to have a device called an artificial kidney and a process called dialysis in order to help people. That was 50 years ago. slowly we recognized that it is possible to miniaturize, to make smaller those processes. And that's what we did. And of course, I'm not the only one. There are other people as well. I started about 53 years ago because I was interested in helping people take their medicine in a simpler way. I, like many others, did not like shots, injections. I preferred something simpler, but I knew that that something simpler was going to be very difficult to absorb in the body and be transferred into the blood. So I had the knowledge of a chemical engineer who could use particles. We call them polymer particles, plastics if you wish, but please don't use the word plastics here because we have found that they are non-toxic, non-carcinogenic, and so on. And we could incorporate drugs, peptides, proteins, and when I say drugs, let's use the word medicines, and be able to enter them in the body and help the body. And so that's how I started. And there was very little. There were a few very good people in Europe, in the United States, but very, very few. And because I am an engineer, I developed the mathematics as well. And the mathematics became very, very popular. Many people still remember some of the original equations that I used, which were used in order to design new products. But the years passed, and the diseases became more difficult. And we got into diseases such as autoimmune diseases, cancer, etc., where the application was not simply taking a pill, a tablet, and being happy. And that became our major effort. So in the last 25, 30 years, that has become very important. And perhaps you don't know it, but the University de La Laguna has been a small contributor also in this, or a big contributor, because one of my former research associates, Professor Edgar Perez Herrero, has become a professor here, and he has developed a series of very interesting technologies for treatment of a variety of diseases, especially a particular type of cancer. And we still work together, we publish together, and so on. So there is that interaction. And there are other professors from this university that I know. So it is a global interaction. There are no barriers anymore. We try to work to save people. Thank you very much for saying this. Yes, I value networking. You noticed from my presentation yesterday, I was born in Greece, and I went to the United States when I was 22 years old. I feel very international. For me, there are no barriers. Whether you are a Spaniard or a Chinese, you have the same cells. And so I have worked a lot with Spain and with many universities and research centers, especially in the last 30 years. Santiago de Compostela, Barcelona, Valencia, Madrid, Complutense, Madrid, Alcalá. I'm missing a few now, and of course, La Laguna. So, and I'm very happy and I'm very proud and I enjoy my life. And as you perhaps don't know, I enjoy also the culture. For me, the culture is something extremely important. Last night I was in the auditorium at the Tenerife with a magnificent performance by a Polish orchestra and an Israeli conductor. And this is my other life. There are medical challenges that are scientific, medical, and have to be solved with our knowledge or parts of our knowledge. But let's not forget that we live in a world directed not by politics, not by politicians, but by governments that have to pay what we do. When I teach my students, I always tell them, you developed a new product. Who is going to adopt it? It's not the patients. The patients cannot go and say, I would like this product. It's the governments. It's the insurance companies and so on. So what I'm saying is the main problems that we have to solve in the next 20 years are many forms of cancer. That is number one. But also the other thing that is important to me is autoimmune diseases. Why autoimmune diseases? Many people start suffering without knowing why, because these are more complicated diseases. So there has to be a process of working with the doctors to identify what the disease is. For example, multiple sclerosis is a process which will lead to disability. People will not be able to walk. It takes a few years for that process. We need to solve it. And I do not want to sound like a teacher, but the question is not simply to find one solution, but to find the better solution. You find a solution for me that says that I have to take injections, shots, 5 times a day. I am glad it exists, but it is inconvenient, especially if I am a worker or if I am somebody who has a business and so on. I have to stop 5 times a day to do that. Can you find a system that works once a day? Can you find a system that works once a month? Can you find a system that works once a year? I think we are going that way. It is making it easier to cure. And I want to stress, we are not medical doctors. We are working with medical doctors. And we work together. Yes, I'm also a professor in medicine at the University of Texas. And I do teach there and so on. But it is in collaboration with other medical doctors. I stressed yesterday that I'm an immigrant because politically, both in Europe and in Americas, we have now many questions about immigrants and what they contribute. I personally worked and have worked in the United States for 54 years. I have not felt that people have excluded me, but I have kept good contacts with Europe. Many visits to Europe. Many visits to China, to Japan, and to Singapore. And always trying to understand the other side. So I think this is important. I think some people get a little bit tired or they have other responsibilities and they forget the main goal, which for me, and I'm sorry if I sound that I say too much, for me is to save people, really, to save people. Looking for solutions and looking for solutions that will improve the quality of life of our patients.
Thank you very much for your time.
Thank you. Thank you very much.